This video is going to cover the 5 basic chemical reactions. The first basic chemical reaction will be the synthesis reaction. The word synthesis means to combine. In this type of chemical reaction, we will combine 2 or more reactants to form only one product. The second type of chemical reaction is called a decomposition chemical reaction. A decomposition reaction is the opposite of a synthesis reaction, where you will have one reactant that breaks up into multiple products. The word decomposition means to break up. The third type of chemical reaction is a single replacement reaction. In this chemical reaction, you will have one element replacing another, which is why it's called single. The fourth type is a double replacement reaction, where you have multiple or 2 elements switching places. And then the last one is a combustion reaction. Each one of these chemical reactions has a general equation and multiple types. You will need a reference table once we start predicting products to help you with these 5 chemical reactions. We're going to start with synthesis. As I said earlier, synthesis means to combine or to create one product. So here you will have 2 or more reactants combined to form one product. Here is the general equation for a synthesis reaction. You can also find this in your reference table on page 6. Here we have our reactants. We have 1, 2 reactants forming or yielding one product. I know that there are 2 reactants here because there's only one plus sign. And I know there's only one product here because there are no plus signs. Here is an example of a synthesis reaction with elements. Here we have calcium plus oxygen yields calcium oxide. When you are trying to identify or classify a chemical reaction, it is important to notice how many plus signs you have on both sides of the chemical equation. In this case, we have 1 plus sign on the reactant side, indicating that we have 1, 2 reactants. On our product side, we have no plus signs. Therefore, we only have 1 product. It does not matter what your coefficients say or what your subscripts are. The only thing that we are concerned about are how many reactants and products you have. Here is a visual to help you with your synthesis reaction. Here we have our 2 calcium atoms combining with our 2 oxygen atoms. They are rearranging to yield or form calcium oxide. Here's where your coefficients are telling you have 2 calcium oxides. Here this coefficient is telling you have 2 calcium atoms. But when we are classifying chemical reactions, your coefficients are not important. The coefficients are simply there for balancing purposes only. The next chemical reaction is your decomposition reaction. The decomposition reaction is the exact opposite of a synthesis. So whereas a synthesis reaction, you are taking 2 reactants to form one product, your decomposition reaction is going to take 1 reactant and break it down into 2 or more products. Here is your general equation for a decomposition reaction. You can find this general equation on page 6 in your reference table. Here we have 1 reactant. I know I have 1 reactant because there are no plus signs. My 1 reactant is going to decompose to yield 2 products. I know I have 2 products because I have 1 plus sign here. Here is an example of a decomposition reaction. Here we have 1 large reactant. We have ammonium nitrate. I know that this is 1 reactant because there are no plus signs. Ammonium nitrate will decompose or break down to yield dinitrogen oxide and water. Our atoms are rearranging, but we still only have 2 products. I know that I have 2 products because I have 1 plus sign. So dinitrogen monoxide is 1 product and water is 1 product. Here is another example of a decomposition reaction. We have copper 2 chloride breaks down and decomposes into copper and chlorine. Again, how many subscripts you have is not important. You are only looking at how many reactants and products you have. Here's a visual to help you understand a little bit better what is actually happening here. Here's our copper 2 chloride where we have our 1 copper atom and our 2 chlorines, and it breaks down into copper and chlorine. Next we have a single replacement reaction. The word single means one. So in this scenario, or with this type of chemical reaction, you have one element is going to replace another in a compound. Here is our general equation for a single replacement reaction. I have color-coded it for you to help you see where these elements are going. Here we have A, which is going to be our single element, plus BC, will yield to produce B plus AC. In this case, element A replaces B, and B gets kicked out. Alright, so your C and your A will be together as a product. Here's a general, or just an equation to represent single replacement. We have copper plus silver nitrate yields silver plus copper nitrate. I've color-coded them for you to help you recognize the fact that copper and silver are switching places here. Copper replaces silver, and silver gets kicked out. Also notice how we have our two metals switching places. Metals replace metals, whereas nonmetals will replace other nonmetals. You should never have two metals as a product. Here's another example where we have magnesium plus aluminum chloride yields aluminum plus magnesium chloride. In this chemical equation, you have magnesium is going to replace aluminum, and aluminum gets kicked out. One easy way to identify if you have a single replacement reaction or not is if you have elements that are single on both sides of your chemical equation, meaning that they are not in a chemical bond, and they are just literally single. Remember that your coefficients are not important when you are trying to classify your reactions. You are only looking at how many reactants and products you have. And in this case, we are looking to see which elements are replacing the others. Here's a visual down here at the bottom to help you see our single replacement reaction. Next, we have a double replacement reaction. Double meaning two. So in this type of chemical equation, you will have all your reactants switching up. For example, here is your general equation. This general equation can be found on page 6 in your reference table. Here we have AB plus CD yields AD plus CB. We have two reactants and we have two products. Notice how as a reactant, your A is paired with B. In the products, though, A is paired with D. Here we have C is paired with D, but in your products you have C is paired with B. So the two elements that switch places are the B and the D element in this general equation. Often these reactions will produce water, or a gas, or a solid. When we get into predicting products for double replacement reactions, we will talk more about the production of water, gases, and solids. Here's a chemical equation that represents a double replacement reaction. Here we have sodium hydroxide plus hydrochloric acid yields sodium chloride and water. Notice how sodium is originally paired with hydroxide, and then as a product, sodium is bonded to chlorine. Here we have hydrogen is paired with chlorine, and at the end we have created water. This is what we call an acid-base neutralization reaction, which we will refer to again when we talk about double replacement reactions and predicting products. Here's another chemical equation that represents double replacement. We have lithium iodide plus silver nitrate yields silver iodide and lithium nitrate. Here a lithium is originally paired with iodine, and as a product, lithium is paired with nitrate. Here sodium is paired with nitrate, and as a product, silver is paired with iodine. Notice how as we look at our products, silver and lithium are not paired together. The reason why is because you will never have, in this chemistry class, you will never have two metals bonded together as a product, which we will refer to again in our prediction of products video later on. The last type of chemical reaction that you need to know about is called a combustion reaction. In a combustion reaction, you have oxygen combining with a compound to give off heat and light. A combustion reaction will be different than our other four chemical reactions because there is no general equation for a combustion reaction. Why, do you ask? That's because a combustion reaction always has the same products. You will always produce carbon dioxide and water. And remember when we say products, that your product will be on the right-hand side of your arrow. So for a combustion reaction, on the right-hand side of your arrow, you will always have CO2 and water. That's a capital O, not a lowercase o, for carbon dioxide, and water. Now, at the beginning, at the very top of this slide where it says that you have oxygen combining with a compound, your oxygen is going to be O, but remember it's diatomic, so we have O2. And that word where it just says compound here, normally it's going to be a hydrocarbon, which means it's going to have a carbon and a hydrogen, like this. So our general equation, we're going to have a carbon and a hydrogen here. But the subscripts for your carbon and your hydrogen can be anything. So I'm going to put an X and I'm going to put a Y here for subscripts because it can be any number. It's an infinite possibility. Here's another equation here for a combustion reaction. Here is our hydrocarbon. Notice how we have one carbon and 4 hydrogens. That's going to be your X and Y because it can be any number. Then we have our oxygen, just like here. And then our products will be exactly the same no matter what. We're going to have carbon dioxide and water every single time. You're also going to produce heat and light, so the container will be hot, and you will see a production of light whenever a combustion reaction occurs. So now that we know the different types of classifying, or we know the different types of chemical reactions, let's take a look at a couple of these. For number 1, we have hydrogen plus oxygen yields water. So the very first thing I'm going to do is I'm going to decide how many reactants and how many products I have to do process of elimination to decide what type of chemical reaction this is. On my reactant side, I have 2 reactants. I know I have 2 reactants because of this plus sign. And on my product side, I have 1 product. Well, there is only one type of chemical reaction that has 2 reactants and 1 product, and that would be synthesis, where we are creating 1 product. Okay, we have time for one more. Here we have zinc plus sulfuric acid will yield zinc sulfate and hydrogen. I have 2 reactants and 2 products. So I can at least eliminate synthesis and decomposition based solely on how many reactants and products I have. So my next options are single, double, and combustion. This is not a combustion reaction because I do not have carbon dioxide or water as a product. So now I've eliminated it down to single and double. Well, I notice that I have zinc by itself and I have hydrogen by itself. In this chemical reaction, zinc has replaced hydrogen and hydrogen has been kicked out. So since I have single elements on both sides, I can deduce that this is a single replacement reaction. Please do numbers 3, 4, and 5 and email me your responses.